In this lecture, we're going to be looking at extrusion cooking as a means of food preservation. And got a couple slides that show you some various pictures or schematic diagrams of an extruder. And this one you can see as you look at the very top of the picture, the schematic, that you have a place for fluid injections. You also have a hopper where you can actually feed solid product into the extruder. Then that product goes through some steam injection system, and then finally enters into the actual barrel of the extruder. And on that extruder barrel, you have different zones where you can control the temperature, as well as areas where you can actually inject various fluids. Maybe something like flavoring, which we'll talk about later on. And then as the material moves through the extruder barrel, you come to a die at the end where there's a knife that will cut it into whatever the shape happens to be. This is an example of a diagram that would show you an extruder that may be used for making pet food. And this is a system certainly where one would have several unit operations certainly involved. You have an area where you can add, on the far left, dry material, and this can go through a grinder. Other dry and wet ingredients can be added as well, and go through a mixer, and then it can be preconditioned with heat or steam. And then you can see the extruder screw at number 3. And you can see that this happens to be a taper screw with different flights of dies present. And then the product, once it's extruded and made into whatever shape it can be made into, it can go into a drying oven and cooler, and then can be moved up to have whatever coating that may be put onto it. Certainly it may be some type of flavoring, and then go to labeling and packaging, and you see the finished product on the right hand side. There are certainly some advantages of extrusion cooking. It's a high temperature, short time process, and certainly can lead to a better quality finished product in terms of texture properties, in terms of nutrient content. It's actually a fairly simplified process, although there certainly can be some issues with extrusion cooking depending on the material that one is trying to extrude, and has certainly application to a large number of products, and we'll certainly look at some of those products in a couple of slides as we go through this presentation. There certainly is some departmental expertise in extrusion cooking, and Dr. Kamari certainly has a great deal of expertise. And you will see as you go throughout this presentation and you look at the slides, a number of these slides were from a presentation that Dr. Kamari used to do when she taught this particular part of FSN 502. Another person who had some connection with the department and is now at Texas A&M University is Dr. Mian Ruiz. Mian was my first PhD student. He now runs a whole extrusion facility at Texas A&M University. He's a professor there, and he's involved in teaching courses throughout the world, actually, related to extrusion technology. A lot of his courses are taught in third world countries. They relate to producing food for humans, but he also teaches a number of courses looking at extrusion as a means of preparing and manufacturing food for animals, particularly, say, fish as an example. So food product applications certainly include snack products such as corn chips, cheese puffs such as Cheetos, veggie chips, as I said, can be used to prepare and produce animal feeds, ready-to-eat cereal, pasta, and texturized vegetable proteins that then can be used to make things such as meat analogs. And this is an example of a slide that shows you a vast array of products that can be produced by extrusion technology. And you just see a lot of different types of cereal and snack type products. Can also be used to make feeds for aquaculture, certainly a growing industry. Can be used to make candy, such as marshmallows, candy canes, licorice, packing materials, those peanuts that one has as a packing material. They are produced by extrusion technology. And then processed cheese. The unit operations that typically might be involved in extrusion cooking would include mixing, conveying, cooking, heating, energy transformation, chemical reactions certainly that occur in the extruder barrel, forming of the product, and in size reduction if we cut that product as it comes out of the die into various sized particles, pieces of food. There are basically two types of extruders. One is a single screw extruder, and this is a schematic diagram of a single screw extruder. As we start with the 8 being the controlling mechanism for that extruder to be able to turn the single screw in the extruder barrel. We have a hopper at 6 to feed the material that we're going to be extruding into the barrel. We have various zones within the extruder where various things occur. Zone 5 in this case happens to be a kneading zone where the material actually becomes mixed. Zone 4 is the cooking zone, and zone 3 is the forming zone. And then as we get to the end of the barrel and we have the die at 2, this is where the actual shape of the product and the size of the product will be determined. A second type of extruder is a twin screw extruder, and this shows you the twin screws, and these can be rotated clockwise or counterclockwise to each other. And as you can see, we have a number of different elements, screw elements within these different twin screw extruders. We have a kneading screw element, then we have a reverse conveying screw element, which is involved in determining the residence time of the product in the barrel of the extruder, and then we have different elements for forward conveying of that material as it gets ready to exit the extruder. The process in terms of extrusion types can be cold forming, where there is no heat involved. Also low pressure, and in low pressure instances the temperature is going to be probably less than 100 degrees C, and then under high pressure the temperature within the barrel is going to be greater than 100 degrees C. And these can be carried out with either single or twin screw extruder. The economics, we might ask why extrusion. Certainly it's important from an economic standpoint in terms of fairly low labor costs. And then there is certainly less wastewater handling because we just don't have wastewater generated. Less equipment might be required, as you looked at some of the systems that I put up in terms of diagrams. And certainly the cost of handling wastewater today is fairly expensive, and by not having any wastewater to handle, you greatly reduced the cost. And it's also a means of producing food products that have unique shapes, textures, and flavors. The one thing you do need to remember is certainly the initial cost for an extruder can be quite expensive. So the initial equipment costs and then replacing certainly the screws can be quite costly. If we look at the essential extrusion parameters and what occurs as we look at the raw materials that are being used or put in through the extruder, if we look at what occurs during the mixing, and then conditioning, and then the extruding and post-extrusion. As we look at the raw materials, the important aspects, certainly the parameters of the composition in terms of, say, protein, carbohydrate, lipid, and what effect they will have on how the product extrudes, and then certainly the water content, and then the particle size of the material that we're getting ready to extrude. When we look at mixing, certainly the essential parameters here include the mixing time and the mixing action, as well as the agglomeration and how much these particular materials actually interact with one another. The important essential parameters during the conditioning include water content, and then certainly temperature, and then the residence time within the extruder barrel. And then finally, as we get to extruding and post-extrusion, the important parameters deal with the barrel length and temperature of the barrel, the configuration of the screw, in other words the screw elements, how many, what types are present, the configuration certainly of the die at the end of the barrel, and then the screw speed. And if we look at the extruder barrel, typically it's much longer than it is wide, and length to diameter ratios may be up to 20:1. It may be tapered in a single screw extruders. In that diagram that I showed you, you could see that extruder barrel was tapered. The lining may be smooth or grooved, and heat can be applied by any number of methods. It might be electrical resistance, it could be oil, it could be water. And then the cooling typically would take place by either using air or water. Things that you need to consider as you look at the screw that you may use in an extruder is deep, wide flights are used to actually move the food through the barrel. The kneading and reverse elements increase the cooking and mixing time by increasing the residence time in the extruder, as I mentioned earlier. If we have shallow, short flights, increase the heat and the shear that occurs in that extruder barrel. Dies, the die hole length, diameter, and shape assist in determining the final product shape and texture. More holes reduces the pressure, and this lowers the amount of expansion that occurs. If you want a very expanded finished product, you would certainly want to have less holes in your die. If you want a product where you don't get much expansion as it exits the extruder barrel, then you would have more holes in your die. We look at screw wear. Certainly screw wear is going to occur as we extrude product over time through the extruder. Barrels and screws typically are made of hardened steel or metal alloys, and certainly iron and other metals actually get shed into the food as we extrude the product. And the iron content within the food product may increase as much as 80% in the finished product versus the iron content of the ingredients prior to extrusion. It may lead to improved nutrition. Certainly one has a greater chance for oxidation, and in products where there are lipid involved in the extrusion product, we certainly need to worry about lipid oxidation with the development of all flavors. And certainly as we do get some allied products being formed, there's a possibility for product discoloration. The cost of certainly the barrels, screws, and screw elements is extremely high, and this is certainly needs to be figured into the economics as one looks at cooking extrusion. Additional equipment that might be used in an extrusion system, and I show you here a fish and pet food system. There may be feeders, pumps, conveyors, cutters, dryers, tumblers, fryers, and rollers. These may be all additional equipment that would be part of a food processing system using the cooking extrusion process. And this is a diagram showing you a breakfast cereal processing line, and as you can see it actually shows you some of the finished product that might come from this. The one down in the far right hand corner is cornflakes. Cornflakes are made by extrusion or cooking extrusion, and the numbered areas are defined for you so you can see what actually occurs during a whole line, processing line for actually breakfast cereals. Interpreting the results from extrusion is often difficult, and it's oftentimes very difficult to repeat published results, particularly research that's being done at universities where the extruders tend to be very small and maybe of non-commercial for non-commercial applications. So if you're doing sort of pilot plant applications for the cooking extruder, and then you try to bring those into commercial extruder as you increase the amount of product you're putting through or scale up, oftentimes major adjustments need to be made in terms of the settings that are used. The University of Maine does have a small twin screw extruder. It's over in the farm store in the back part of that building. The main ingredients, we'll be looking at some of those that may be used in extrusion. Certainly, oftentimes, we're extruding starchy materials as well as proteinaceous materials. and water, and these all provide the functional properties as we look at, provide functional properties as we look at cooking extrusion. There are some instances where lipids are also used, but most instances when we're looking at cooking extrusion, we're not looking at high-fat products. What chemical changes can occur? Certainly thermal degradation, because we do in a cooking extruder generate a fair amount of heat. We can depolymerization of some of those functional ingredients as we look at proteins and we look at carbohydrates. Then once they depolymerize, we can get certainly recombination of the fragments that have been formed, and then binding of macromolecules to one another. Lipids will affect the extruder performance. They will affect torque. They'll lower the torque. They'll decrease the expansion. Something you need to take into consideration as you look at extruding products that may be fairly high in lipids. Certainly one can see hydrolysis of the lipids, and this can certainly lead to free fatty acids and glycerol. The free fatty acids, if we look down at the very last step, point increased oxidation. Certainly we have metals on the surface of the barrel and on the screw, and we have large surface area, and then we also have malate products being formed. And then lipids can form complex formation and combine with amylose and increase extractable lipids. Starch is involved certainly in gelatinization that may occur at low moisture levels. One does get a shearing of the amylopectin branches from the starch as one goes through the extrusion process. And we get a decrease in molecular weight of amylose and amylopectin as they're broken down into smaller pieces. Then complexes can form, as we mentioned in the previous slide, between amylose and lipids, and we can also get transglycosidation occurs. And if you don't know what transglycosidation is, I've defined that on this slide as a transfer of glycosidigly bound sugar to another molecule. In other words, the sugar molecules may then bind to either proteins or lipid that are ingredients or materials within the extruder. The functionality certainly of starch in a cooking extruder is involved certainly in expansion and improving the strength of the finished product. Starch will be involved in moisture uptake. It will increase certainly the water holding capacity. They will certainly add flavor, and starch functionalities, they also act as binding agents as we go through the extrusion process. Protein functionalities include fibrous texture formation. This is extremely important as one looks at the production of meat analogs using extrusion technology. Texturized vegetable proteins being one example, soy protein isolate, another example of something that might be used certainly in producing meat analogs. They have an influence on the rheological properties of the extruded product. They may alter the shear value. Certainly proteins do contribute to flavor formation, and proteins will add high nutritional value to our extruded, finished extruded product. Denaturation of the proteins does occur during the extrusion process. Since we have some water present, we also have very high temperatures, and as a result of this, solubility decreases. Lysine is lost during maillard and other chemical reactions, so certainly the lysine content of a finished extruded product will be lower than the lysine content of the products prior to extrusion. Can lead to certainly improved digestibility, as it's more apt to be broken down by digestible enzymes. And texturization, as I mentioned, certainly with fibers and as well as with gels. Dietary fiber. Dr. Kamari has done quite a bit of work looking at the effect of extrusion on dietary fiber, and she's published a fair number of papers actually looking at this particular aspect of cooking extrusion. Different conclusions are based upon differences among analytical methods that are used to determine the dietary fiber content once the product has been extruded. Molecules become more soluble in water, but that increased solubility does not mean the same health benefits as if the actual fiber was a soluble fiber. And total fiber may increase during the extrusion process. Increased vitamin retention is based on certainly a low temperature during extrusion compared to, say, temperature that might be used in producing a commercially sterile product such as through canning. We have a slower screw speed will result in better vitamin retention, higher moisture content, a larger die diameter, and lower specific energy units. These all will result in an increase in vitamin retention in that extruded product. How does extrusion improve food safety? Well, certainly potential foodborne pathogens that may be associated with any one or more of the ingredients that we're extruding are destroyed. The high temperature and the pressure in the extruder will also result in inactivation of enzymes that could cause changes in the properties of that food product, adverse quality changes. One may see the destruction of low molecular weight toxic compounds, and then one will also see at the high temperature the inactivation of some anti-nutrients that may be associated with one or more of the ingredients. And we'll discuss each one of these areas a little more in depth in the next few slides. So reduction in microorganisms, what causes that to occur? Well, certainly it's a result of one thing, the high temperatures that we reach during the extrusion process, in some instances greater than 150 degrees centigrade. The residence time in the extruder barrel, which may exceed 40 seconds. And certainly, depending on the extrusion parameters that are set up, the actual extrusion process may equal those that one obtains during commercial sterility as one looks at thermal processing and canning of a food product. Usually, the finished products have a very low total microbial count. Enzyme inactivation, certainly the enzymes that may be present in the food product prior to extrusion may be deuterative. They may actually break down lipids. They may be able to be proteases or lipases that would be involved. They also may be glycosidases. They also can be enzymes that are involved in the formation of toxic compounds. Certainly the inactivation of these enzymes as a result of the high temperature and the residence times in the extruder barrel will increase the shelf life of that particular extruded product and will improve food safety. And the inactivation is a result of three parameters: high temperature, high pressure, and the high shear forces. Let's look briefly at the inactivation of anti-nutrients. Certainly anti-nutrients are found in legumes and root crops, and they may be reduced by up to 95% by extrusion. And this is facilitated by the very high temperatures, the low moisture content, and the low lipid content in these products during the extrusion process. Destruction of toxic compounds, many are heat resistant. Aflatoxins, fumonisins, produced by Fusarium, it's a fungi that grows in wheat and maize. Trichothecenes, those that are important certainly and been shown to have toxicity to humans. Shellfish toxins and glycoalkaloids. One may see only a partial decrease in these toxic compounds, as many of these toxic compounds are fairly heat resistant. Chemicals certainly that are incorporated before extrusion may enhance detoxification of these materials. Why are many extruded food products bland? Well, certainly the extruded process or extrusion cooking allows for little time for flavor development, and the thermal degradation occurs under high temperature short time processing. As well, with the high temperatures, high pressure, many of the volatile flavor compounds actually vaporize when the food exits the extruder die, and one gets the actual increase in size of the product or expansion. Thus, most extruded foods are flavored, particularly snack foods, and we'll look at some of the mechanisms that can be used to actually incorporate flavor into these extruded snack food products. Maybe flavoring following extrusion, so the product is extruded and then the flavoring is added, and oil-based savory seasoning coatings may be used. The oil provides an adhesion base. It improves the product mouthfeel. It does increase the calories, which may or may not be a good thing. It increases, again, the fat content, as most of these oils are vegetable-based, not as bad as if they were animal-based. And certainly introducing oil through the seasoning can increase lipid oxidation. Using an oil-based savory seasoning coating, the application may very well be uneven. Typically, tumbling is used as a means of getting that seasoning on the product, and certainly the flavor coating may rub off through the packaging operation and through storage. If it's added prior to extrusion, one can see very high losses due to a number of things. Certainly, thermal degradation can occur at the high temperatures and pressures in the extruder. Some of the flavorings actually may bind to other macromolecules, and we lose their effect as a flavoring. And then steam distillation and loss of the flavoring materials, compounds, as they vaporize as the material exits the die and it expands. Differences in flavor retention due to methods of addition, direct blending in the feed, or injection into the extruder are two ways, certainly, that it can be done, but in each of these instances, again, we certainly can see losses in flavoring, but perhaps not as large as some of the other methods. Injection reduces the radial expansion and reduces the amount of flavoring that is retained. Encapsulation is the best way to go, but encapsulation of flavors is quite expensive and would add a significant amount, certainly, to the final product cost. And finally, the last slide provides you with some references for research that was done at the University of Maine, as we looked at extrusion technologies, looked at its influence on dietary fiber composition and a number of different meals and potato peels. Some work that Dr. Kamari did. Some work that one of my graduate students did along with Dr. Kamari, looking at extrusion to produce snack food products using potato flakes and spent fowl, such as chicken thigh meat, as an example. And this concludes the lecture on extrusion cooking.